Meet our chemist, Harriet. She has a chemical reaction that needs to occur more quickly. Our chemist has some processes at her disposal that can help her speed up her reaction, and she knows of 5 ways. And to remember them, she thinks back to her days as a high school student, and the day she got a date for the dance. Harriet was in high school studying between classes. She had lost track of time and was going to be late to class. Unbeknownst to her, Harold, who was just around the corner, was running late too. They both sprinted to class, and as it happened, sprinted directly into one another. Now, this was no small collision. They ran squarely into one another in such a way that he knocked the books right out of her hand. "I'm sorry," he said. "Let me help you with your books." He kindly helped her recollect her belongings and politely offered to walk to her class. You'll never guess who went together to the dance later that year. Yep, those two. So as we can see from this example, the key to getting a date for the dance is to collide with someone and knock the books out of their hands. Now you're probably already aware that not all collisions lead to dates for the dance, thankfully. The collisions must have 2 important characteristics. 1, correct orientation that allows books to be knocked from one's hands, and 2, enough energy to knock the books out. Shortly after this incident, Harriet decided to tell me, her chemistry teacher, all about it. I noticed some interesting parallels between her story and chemical reaction rates, which happened to be what she was studying in the hallway at the date of the collision. Together, we decided to set out on 2 missions. Harriet wanted to help all chemistry students and chemists remember how to speed up the rate of chemical reactions, and I, the nice guy that I am, decided to make it my mission to help create educational environments in which more book-dropping collisions can take place to increase future chemists' chances of getting a date for the dance. In order to facilitate this improved dance date-getting process, I propose 5 changes to all schools that parallel Harriet's 5 ways to increase chemical reaction rates. First, I propose that we shrink the size of the hallways. This will make it more difficult to safely navigate the hallways and will cause more collisions than in larger hallways. And by increasing the number of collisions, we increase the likelihood that some of those collisions will have the correct alignment and enough energy to create a date for the dance. Now, chemically speaking, this is equivalent to lowering the volume of a reaction vessel or a reaction mixture. In doing so, the individual particles are closer together and more collisions will occur. More collisions means a greater likelihood that collisions with the appropriate energy and configuration will happen. Second, I propose increasing the overall population of the school. More students equals more collisions. By increasing the number of particles available for collision, we create an environment where more collisions will take place. Third, we must reduce the time allowed between classes. Heck, let's just cut it in half. In doing so, students will need to move more quickly to get from one class to the next. This increase in velocity will help make sure collisions have the appropriate amount of energy necessary to ensure book dropping. This is analogous to increasing the temperature of the reaction mixture. Higher temperature means particles are moving faster. Faster moving particles means more energy, and a greater likelihood of reaction causing collision. Fourth, students must stop traveling in packs. By traveling in packs, those students on the outside of the pack insulate those in the middle from undergoing any collisions. By splitting up, each student has more area exposed that is available for a collision from a passing student. When particles travel in packs, the surface area is very small, and only the outside particles can collide. However, by breaking up the clumps into individual particles, the total surface area is increased, and each particle has an exposed surface that can react. Fifth, and finally, we hire a matchmaker. Is this colliding and book dropping too violent? Is there an easier way to get a date that requires less initial energy? And a matchmaker will help with this. A matchmaker makes it easier for a couple to get together by coordinating the match. Our matchmaker is like a catalyst. Chemical catalysts function by lowering the activation energy. In other words, by lowering the energy required to start a reaction. They do this by bringing 2 particles together and orienting them correctly in space so that the 2 can meet the correct configuration and allow a reaction to take place. So, to sum up, if a future chemist wants a date for the dance, he must collide with another person and knock the books out of their hands. And if a chemist wants to make a chemical reaction occur, the particles must collide in the correct orientation with an appropriate amount of energy. And both of these processes can be accelerated using the 5 methods I've described.
In this video, you're going to learn what a catalyst is, how a catalyst works and where catalysts are used in everyday life. Firstly, what is a catalyst? A catalyst is something which speeds up a chemical reaction, but at the end of the reaction has the same mass as it had at the beginning of the reaction. This means that it is not used up in the reaction. It must, however, take part in the reaction, or we might as well not have it there at all. So, how does a catalyst work? A catalyst works by providing an alternative pathway for the reaction to occur. This alternative pathway has a lower activation energy than the pathway without the catalyst. Here are the two pathways for a reaction. The blue pathway is the energy profile for the reaction without the catalyst, and the red pathway is the energy profile for the reaction with the catalyst. You can see here that with the catalyst the activation energy is lower. As a result of the activation energy being lower, there are more molecules with the required activation energy, and so more fruitful collisions occur per second, and hence the reaction is faster. Do you know where catalysts are used in everyday life? Most manufacturing processes are exothermic for economic reasons. The heat given out is used to maintain the operating temperature of the reaction. Exothermic reactions cannot run at too high temperatures as the yield will be too low. So, as we cannot increase the rate of these exothermic reactions by having the temperatures too high, we use catalysts to increase the rate of reaction. Here are two manufacturing processes that use catalysts. Firstly, the Haber process to manufacture ammonia, most of which is used in fertilizers. In this process, iron is the catalyst. The iron has potassium oxide, which acts as a promoter, added to increase its efficiency. And secondly, the contact process to manufacture sulfuric acid, which is used to make detergents and fertilizers. Vanadium 5 oxide, sometimes known as vanadium pentoxide, is the catalyst in the contact process. Catalysts are also used in catalytic converters in vehicles. These catalysts remove toxic exhaust gases by converting them into harmless products. So, to recap, catalysts speed up chemical reactions without themselves being used up. They work by lowering the activation energy and are used in the Haber process, the contact process, and in catalytic converters. Thank you.